Okay, today we are talking about chapter 2.5, which is all about estimating with two-digit divisors. Okay, and our learning goal for today is to be able to estimate quotients using compatible numbers. So let's take that apart a little bit. What does it mean to estimate? What does it mean to estimate? Liam?
Make an educated guess.
Make an educated guess. Does it mean finding an exact answer?
No.
So looking at today's learning goal, does it look like today we're going to be concerned about finding exact answers? No, we're going to be estimating. What are we estimating? It says estimate quotients. What does that tell you? What does quotients mean? Joseph?
Quotient means the answer.
To what kind of problem?
A division problem.
The quotient is an answer to a division problem. So we're going to be estimating the answers to division problems using compatible numbers. What does compatible numbers mean? Tanvi?
Numbers easy to work with.
Yeah, numbers that are easy to work with. So today we're going to be estimating with division problems using numbers that are easy to work with. Okay? So the first question I want us to think about today is how can we use basic multiplication facts and patterns to help us estimate? Okay, so let's take a look at these division problems and let's see if we can notice a pattern. Okay, let's start with number 1. 35 divided by 5 with a quiet answer hand is how much? 35 divided by 5. Marcus? Seven. Right? 35 divided by 5 is 7. That's a basic math fact that we all know. Okay, now what happens if we multiply the dividend by 10? What's 350 divided by 5? Ariel? 70. Okay. What's the difference between the first equation and the second equation? Daniel?
You just added, put a 0.
When I have a 0 in the dividend, and did I add any zeros to the divisor? No, so I have 1 0 in my quotient. Interesting. Okay, what happens if I have a 0, 350 divided by 50? What is 350 divided by 50? I now have a 0 in the dividend and a 0 in the divisor. What's the answer then? Karan? 7. Oh, is there any zeros inside the quotient? 350 divided by 50 is 7. That's right. Okay, let's take a look at this one. 3,500 divided by 50. What is 3,500 divided by 50? Stuart?
70. Yes.
70. Okay. Let's take a look at the next one. 35,000 divided by 50. What does that equal? Matthew? 700. What patterns are we noticing? I want you to take a look right now and look at how many zeros you notice in the dividend, how many zeros you notice in the divisor, how many zeros you notice in the quotient, and what's the relationship, what's the pattern there? Go ahead and turn and talk with your table group. Yeah, so we know that 350,000 divided by 50 is going to equal 7,000 because we can use what we know about basic facts. Do we know that 35 divided by 5 is 7? Right, so this part we know because of a basic math fact that 35 divided by 5 equals 7. And then with the zeros, we can use with the pattern we notice. We notice that the number of zeros in the dividend minus the number of zeros in the divisor is going to give us the number of zeros in the quotient. So in 350,000, how many zeros are there, Jason? As Jason said, there are 4 zeros in the dividend. How many zeros are there in the divisor here? Arushi?
In the divisor, there are 1.
There's 1. So if there's 4 zeros in the dividend and 1 0 in the divisor, how many zeros does there need to be in the quotient, Thomas? 3, because there's 4 minus 1 equals 3. So this is how we can use basic multiplication facts, right? Basic math facts, and this pattern of zeros to help us estimate numbers. Okay, let's take another look at another example. So now let's take a look at this problem. Of course, you do not need to copy down the whole problem into your notebook. You simply need to write down the math when we're thinking about the math, okay? It says, the observation deck of the Willis Tower in Chicago, Illinois is 1,353 feet above the ground. Elevators lift visitors to that level in 60 seconds. Okay, so the elevator travels 1,353 feet in just 60 seconds. The question's asking about how many feet do the elevators travel per second. So of course, step one when we have a word problem is always to do what, Joseph? Is the first thing we do whenever we see a word problem? Oh, first step is to divide. Is that true? What's the first step we do whenever we have a word problem?
We have to figure out what the problem is asking.
We have to figure out what the problem is asking. So Joseph, what is the problem asking?
About how many feet do the elevator travel per second?
About how many feet do the elevators travel per second? What's step two every time we have a word problem? Adam?
Find information you need to solve the problem.
Yeah, we need to find the information. So what information do we need to solve this problem? Yes, Mr. Greenberg.
The tower in Chicago, Illinois, goes 1,353 feet above the ground,
Uh-huh.
and the elevator lifts a person the level in 60 seconds.
Yeah. Is there any other key word that we need to solve this problem? To make sure we solve it absolutely correctly and do exactly what the question is asking? We are looking at if it travels, but do we need to find exactly how many feet it travels per second? About. Is it important that the question's asking us only about to find out about how many feet? Yeah. Yes, that 1,353 divided by 60 is pretty close to 1,200 divided by 60. Would you agree that that's true? It also says on the other side, on the other hand, 1,353 is pretty close to 1,800. Why do you think the book chose to use these two numbers, 1,200 and 1,800, to divide by 60 and to use for the estimate? Why do you think these two numbers were chosen, 1,200 and 1,800? Daniel? Clarissa noticed that if you ignore the zeros, you have 12 divided by 6 and 18 divided by 6. These are numbers that are multiples of 6, and that's why they're compatible numbers, because they're easy to divide and easy to work with. Now, why didn't they choose like 1,800 and 2,400 to work with? How come they chose 1,200 and 1,800? Look at how those numbers relate to the original number of 1,353. What do you notice? Yarden?
Because they're closer to the real number, if it's 2,400, it would be not a good estimate.
Sure, so they estimated, they chose numbers that are close to the original number. What else do you notice, Sarah? They are compatible because they're easily divisible, but let's take a look. Is 1,200 less than or more than the original number?
Less.
What about 1,800? Is that less than or more than the original number?
More.
So we're picking one estimate that's a low estimate, that's lower than the original number. We're picking another estimate that's a high estimate, that's higher than the original number. Why is that maybe a good idea to pick a low estimate and a high estimate? Why is that a good idea? So let's first find the low estimate, the estimate that's going to be lower than the actual answer. Well, we can use patterns and basic facts to help us estimate. So let's start with the math fact. 12 divided by 6 is what? 2. Then if you add 1 0 to each one, 120 divided by 60, what's the answer going to be if I have 1 0 in the dividend and 1 0 in the divisor? Do I need any zeros in the quotient? Nope. So 120 divided by 60 is also 2. Okay, let's look at the zeros here. We still know that 12 divided by 6 is 2, but how many zeros do we need? We have 2 zeros in the dividend and 1 0 in the divisor. So how many zeros do we need in the quotient, Jason? 1. So then 1,200 divided by 60 is 20. Let's take a look at our high estimate, the one that's going to give us an estimate that's higher than the actual answer. 18 divided by 6 is 3. Now let's add 1 0 to both the dividend and the divisor. So 180 divided by 60 is, what's the answer? 180 divided by 60 is what, Marcus? Now, are we at the problem we need yet? Nope, we had to add one more zero to the dividend, right? 1,800 divided by 60, because that's the problem we have up here, right? So let's do the basic math fact first. 18 divided by 6 is still how much? 3. And then we have 2 zeros in the dividend and 1 zero in the divisor. So how many zeros are we going to need in the quotient, Zara? 1. So if 1,200 divided by 60 is 20, and 1,800 divided by 60 is 30, we know that the elevators must travel about 20 to 30 feet per second, right? Because is our actual answer going to be in between these two estimates?
Yes.
Yeah, okay. So therefore, we know that the elevators travel about 20 to 30 feet per second. Which one is a more reasonable estimate, 20 feet per second or 30 feet per second? Which one's going to be closer to the real answer? Yanming?
20.
Why is 20 feet per second going to be the closer answer?
1,200 is closer to 1,353
Yeah,
than 1,800.
exactly. Okay, so we know that's going to be in between, the real answer is going to be in between 20 seconds and 30 seconds, but it's going to be closer to 20 seconds because the real number, 1,353, is closer than to 1,200, okay? So, the observation deck elevators in the Willis Tower travel about 20 feet per second.